Okay, welcome everybody. How was your lunch? I hope you enjoyed it. In Germany we have this word Schnitzelkoma. I hope that A, you understand what it means, and B, that it's not describing the state you're in right now. Anyway, thanks Sean for the introduction and thanks for having me again. I think it's really awesome how this turns out year after year and how you're able to raise the bar again and again. So I think this is well worth a round of applause as well. And if you still need an idea for where to host Laracon next year, I think we can all agree that Berlin would be the place to be, right? Okay, so as Sean said, I've been a Laravel contributor for quite some time. I've founded the meetup in Berlin, and I got into the framework because I was maintaining the forum software that Taylor was using back then. And I got into contributing a lot on GitHub, and I learned to navigate my way around the source code, which is in the end always the single source of truth when you want to extend the framework and do stuff with it, even though it has an awesome documentation, of course. And since then, I've been working on Flarum, which is beautiful, modern forum software for the web of today. It's written in PHP and uses many of Laravel's components. So I've gathered more experience with that in mixing and matching these components and integrating them with third-party libraries. Which brings me to what this talk will be about. There's, of course, many things that Laravel as a full-stack framework already offers to you. But sometimes there's just this little thing that's missing or that you want to change from how the framework behaves by default. Or you might want to integrate third-party libraries into the framework. Now, of course, we've got Composer and we've got autoloading, so you might say, what else do I need? Well, from my perspective, one of the greatest strengths of Laravel is its expressive syntax, and I believe this is something that brought many of us here. So combining separated, self-contained, decoupled library with that expressive syntax and making it feel like part of the framework is a great thing to me. So when I gave this talk at Laravel Live UK in London this year, I walked through creating a package that integrates Google's reCAPTCHA solution into Laravel and really making it like it's just part of Laravel. So for displaying a captcha, all you needed was this simple tag in your blade view. And for validating it, the response by the user on the server side, all you needed was this little human validation rule, which took care of the communication with Google and so on. And all of this was, of course, backed by Laravel's config system and that stored the credentials and so on. So this was a nice demo, but there are countless packages already offering something similar. And it also turns out that it's quite hard to select all images with street signs live on stage. Yeah, anyways, so I searched for other ideas what we could do on packages, and it turns out all the good ideas are basically already implemented. There's also packages with a Laravel prefix for it, and mostly they come out of Belgium, as we all know. So I needed something else. The good ideas were gone, so I had to go with the bad ones. Not bad as in horrible, of course, but bad as in evil. It turns out there are very few packages advertising doing something malicious to a Laravel app, so that's what we're going to do today. So welcome to making Laravel painful again, live. To do so, to customize the framework in some way, we need to understand a bit about its internals, though. And I've structured this into 4 parts. First, we'll talk about the IOC container, which I'm sure you've at least heard about if you're using the framework. Yeah, this container is such a fundamental thing to Laravel's architecture that there are entire talks on the subject. We'll just give it a quick overview. After that, we'll talk about service providers, which basically take care of configuring that IOC container and filling it with bindings and and factories. After that, we'll look into managers. As you know, Laravel as a framework has many more things than most apps needs. At least I haven't seen an app that connects to MySQL, SQLite, and Postgres at the same time, and then stores query results in Redis and memcached and on the file system, and distributing that across S3 and Dropbox and local files. So these kind of abstractions are implemented through managers, so we'll take a look at those too. And finally, we'll take a look at how requests pass through the Laravel app as they come in from your web server. Because that's what we need to understand what points are open for extension and where we can hook into the framework. OK, so let's start with the IOC container. The IOC container is basically two things. First of all, it's like a global registry of services that your application needs. It's like a giant array with superpowers, I guess. So if you need a database connection, all you need to do is ask the container for the db.connection item, and it gives you a object implementing the connection interface from Laravel. You don't need to care about where and how it's instantiated, which database you're connecting to, and so on. So this is basically inversion of control, and the container makes that possible. And the other part of what it does is creating these dependencies for you. It does that through a whole lot of magic on the one hand, and on the other hand, it sometimes needs a little bit of help from you. This might be when you're asking for an interface. You obviously need to tell it somehow what implementation of that interface should be returned. And there might be objects that have constructed dependencies that are just not automatically resolvable when you're just looking for types. OK. So when you want to customize Laravel, the container is basically the main point of interest here, because it gives us access to all these objects in our application. And we obviously need to call some methods or change properties or replace them with other bindings to do things. And it turns out many components in Laravel offer methods for extending their behavior, registering new drivers, even adding new methods like the collection macro thing. You can add new directives to Blade, or add entirely new rendering engines to the view layer if that's what you like. And many of these things are documented, some aren't very advertised in the documentation, and some are even forgotten by the developer of the framework himself from time to time. So it's absolutely worth to go digging into the source to find these. And we'll talk about good places to go digging in a bit. So next, service providers, another very fundamental concept in Laravel. Have you ever var dumped an object that had a reference to the IOC container in Laravel? The response was probably not very helpful, because there was a giant array of bindings and factories all dumped all over your screen. So obviously these factories have to get into the IOC container somehow, and service managers is where that happens. So Laravel itself uses service providers to bootstrap the framework, basically. I don't know, the framework has maybe around 30 service providers or so, one-ish per component. And those are registered early in the request lifecycle, when we are still deep in framework territory and none of your app code has yet been executed. And they're very simple PHP classes with two methods, mostly, register and boot. To look at what they're doing, let's take a look at an example. The register method is basically responsible for announcing what services a library or a component provides to your application. So in this example, this is the encryption service provider from Laravel's encryption component. All it does is, in its register method, is register a new binding, an encryptor service, which is instantiated with two string parameters, which this factory pulls from the application config. And this is a very common pattern. the register part of your service providers is usually turning app config into service objects in some way. Okay, but we have two methods. The boot method is called after every register method of every service provider has been called. So this is important to keep in mind, because when you're registering services in your register method, you cannot rely on any other service provider having been called before. So this order of execution gives us a very important guarantee. A, that in your register method, basically you can assume anything about the application state or the state of the container, but in the boot method you can be sure that any other service provider had a chance to register its services at least once. So that basically tells us not to rely on the order of service providers, again, because in register other dependencies might not have yet been registered before. So all you should do in your register method is put stuff into the app. Usually it's going to be service bindings. You might add additional config flags or register assets. I think that's a typical thing for register as well. And on boot, on the other hand, should be used when you want to pull stuff out of the application, use services to call methods on them, extend them in some way, or connect them to the other components. That's what Laravel does in its service providers. Okay. So you can imagine these service bindings like envelopes with a recipe inside. So in the first phase of booting Laravel, people can come to the counter, hand over their envelopes with service names on them, and the person behind the counter, the container, won't look into them until the second phase begins, when people come and ask for them. And again, this helps because services will only be registered, will not be resolved, instantiated, and so on before they're actually needed. Okay, so let's put this into practice. I've prepared a little package here called Larafun. We're obviously going to be having some fun with Laravel, and I've added an empty service provider. So because we want to make Laravel development painful, we need to think about how we can introduce unexpected or annoying behavior into Laravel. And of course, what's more annoying than how to track bugs or how to debug bugs that you haven't seen before, how to track bugs that appear randomly, and how to reproduce. So we need some randomness. So we're first going to register a service, or bind it. I've created a little class that helps with introducing that randomness. It will sometimes, let me write this first. I'll give it a percentage. So this will, when called later, only execute some of the stuff that we do to make Laravel development painful, only 3% of all requests. So we can use this binding now in other places, for example, our boot method. And I've put this into a binding here because it makes it easy to exchange this dependency. For example, for real-world usage, we can wrap it with a, let's do this here, a smart lottery, which will actually not do anything if the request seems to be from a developer. So in the local environment, in the console, or when you're requesting things from a .dev or .local domain. Okay, for now, because we want to actually demo the failures, let's go with a lottery that always shows the annoying behavior. Okay, now we can swap that out easily and change back and forth, and now we're actually going to be using it. So as a first example, let's make database queries slow sometimes. So of course we're hooking into a component here, the database component in this example, so we need to put this into the boot method. And Actually, first we need our lottery, because that determines when these extensions will be called. So I need to pull this out of our container, unless somebody else calls this method before. This is where the instantiation will happen. And now we can actually have to look up the method name. Okay, and now we have a one-off method that we can pass a list of closures to, and one of these closures will execute when our lottery says, let's have some fun with the user. So we'll have varying bad behavior when visiting our app, which is a great way to challenge the demo gods, as you'll see. Okay, so we want to hook into the database component. So many of Laravel's components offer special methods for extension. I've talked about that. So for example, our database facade has the listen method, and that accepts a closure as an argument. That's like an event listener that will be executed every time after a query has been executed. Since we don't care about the results, we don't need any arguments, and all we'll do here is a random sleep between 1 and 3 seconds. Okay, let's try this out. I have a basic Laravel app open here. Okay, this will be hard to see. You will probably, see the waiting for local hosting in the bottom corner. So sometimes it takes longer, sometimes it doesn't. Okay, let's do one more thing. Let's have some fun with logic in Blade. So as you might know, Blade is a compiled template engine, which means that the first time Laravel renders a page, it will take that Blade template, compile it down to PHP, and then use that PHP file, cache it, and use that every time the page is rendered again. So we can hook into that compilation process and do something to the PHP file that wasn't really in the Blade template. We can. So we'll add another closure to our lottery selector. And now we can hook into Blade, which has this extend method. And that accepts a closure with one parameter, that is the template as a string. And that will be called before any of Laravel's directives will be compiled. So we'll still have @if and stuff like that in the template. So we'll do a bit of string replacement in here. So basic stuff. Okay, and what we'll do is we'll replace any if statements. And we'll also respect developers' style conventions, of course. We'll replace those if tags, go away, with if conditions that mostly do what they're supposed to do, but just sometimes every 100th request maybe won't do what they're supposed to do. Okay. And now we're doing an AND. So actually, because Blade compilation only happens so rarely, we need to put this up here. The randomness is guaranteed in the template itself. Okay. Laravel stores these compiled views in the storage framework views directory. So let's just, this is what's in there right now. We'll delete that. And if we refresh our app, okay, we'll have a bit of randomness here. Good luck finding that bug later. Okay. Okay, as you see, service providers are very fundamental both to Laravel in terms of functionality, but they can also be very useful to packages because that's the place where we interface with all of Laravel, basically. In fact, the reCAPTCHA package I was talking about earlier consisted of two things, basically, a composer dependency to Google's reCAPTCHA SDK, and one service provider that did all the integrations. Okay. So let's talk about managers. As we've heard, many components in Laravel have drivers and adapters for different backends. You know that from the database, caching, file system, we have mail services, and so on, queue backends. And you've seen these in the config. For you, it's just swapping out one string for another in your application's config. But Laravel, this is an incomplete list of the components that offer these drivers. Laravel uses the same pattern for implementing those drivers in all of these components. If we want to take a look, so instead of binding a driver implementation in the service provider, it instead binds a manager class. And that manager class is what you're talking to when you're using, for example, the DB facade. Then you're talking to database manager. When you're using cache, : put, or set, or get, you're talking to the cache manager. And what these managers do is let's take a look at the hash service provider, because you can even use different drivers for hashing. So those managers have different methods for creating those drivers. They do the same as normal service providers, using the config to instantiate these objects. This can be sometimes more, sometimes less complex. And every time you call a method on that manager class, through a facade, for example, this driver will be instantiated lazily, and then that method will be forwarded to the driver. And because it has that driver support, we can also request and use other drivers. So if I have a default driver of bcrypt for hashing, I can just call methods normally on the hash manager. But if I want to use another one, I can use it like this. So let's also make use of this. At this time, our app developer will probably have heard of some reports of weird behavior, so they maybe added some logging all throughout the app to find out what's going on. And so we're going to make that hard for him as well, for them as well. So what we're going to do is extend the logging, which is also a manager, and thus supports extension. So in this case, we want to do this every time that our lottery decides we're doing bad stuff, but no matter which of the other extensions will be active. So I have another method here, which executes all of the closures that it will be given, but only when the lottery decides it's time to cause some pain. Okay, so in here, we're going to use our log facade, and we're going to call extend. And this method needs a driver name. I'll call it quiet, because this logger doesn't really do anything. And a closure that returns a new quiet logger instance. Again, I've already implemented this. This just implements the standard PHP logger interface, but forgets to actually do anything. Okay. In the case of logging, we actually need to add a bit of config as well, because logging has this combination of both channels and drivers, so we need to configure the quiet channel to use the quiet driver. So logging, channels, quiet, use that, oops. Okay, and now if we call log debug, oh, actually we have to use that channel, right? So nothing will be logged to further the pain felt by the developer. But it will only happen for those requests where they're actually interested in seeing something. Okay, but of course we don't want them to require this or know about this channel name. So what we'll do instead is set this required driver as the default driver for the logging layer. Okay, so now all messages will disappear. Okay, point being, anytime you want to extend a component, add a new driver, go through the component, look for the manager, and it will probably have an extend method or some other way to be extended to add additional adapters. And if it doesn't have those, you can always replace its binding with a subclass of itself and do all kinds of things. Okay. Last but not least, let's talk about how requests pass through Laravel, both console requests or HTTP requests. So when Laravel starts up, it first instantiates an IOC container and fills it with some basic bindings. Services like the event dispatcher and a logger are set up this early. After that, it loads your application config and sets up error handling, so stuff that needs to be happen really early in the call stack. And finally, it registers all the service providers, all meaning service providers from your application, service providers from Laravel itself, and those automatically discovered in external packages, which is how our code gets into our app. Okay, so at this point, we're basically done with booting the app. It's now ready to accept requests, and all configuration is turned into services. So we can handle requests. And that happens by first loading. Let me take a step back first. At this point, the process diverges slightly for console versus HTTP requests. We'll only talk about the HTTP side of things now. So first, the application loads the routes, determine which route is matched by the current request. Then it sends that request through the global middleware stack, which does things like starting the session, authenticating the user based on cookies or headers. Finally, we have a route. We know which route should be executed, so we also execute the route-specific middleware. And finally, the actual request handler, which might be a controller or a closure from your routes file. Okay, so this shows us the various points where we could hook into this lifecycle. First and foremost, there's middleware, which allows us to basically wrap code around request handling, so do something to the request before it goes into the application, and do something with the response that comes out. And there are also various events thrown, for example, by the router and the HTTP kernel. So let's use these to have some more fun. First of all, we will log out users from time to time when they come visit our app. We obviously need to do this before the request is actually handled. So in this case, we'll use another extension point of the routing layer, which we can access through the route facade, and that has a method called matching. Again, you can provide a listener for that event. Okay, and in here we will retrieve our authentication adapter from the application. Now we need to do a little check that we're not dealing with stateless authentications, such as in an API layer. Okay, and now we can call logout on that request. Okay, so some of our requests will lead the user to be logged out now. Let's try this out. You can see the home link up here. This should take me to my personal dashboard. Okay, now we're waiting a few minutes. I'll refresh again. Waiting again. Oh, sorry, wrong name, of course. It's called matched, my bad. So we were hitting this code. Okay, still logged in. The joys of randomness, there we go. Okay, now we're logged out. Okay, what else can we do? Maybe something after the response has been generated. Let's replace some of the responses with error responses, or at least with responses that look like error responses. And we can do that by listening to another event. This one comes from the HTTP kernel and is thrown every time a request has passed through the entire application. A response has been generated and is ready for being returned, but just before it's being returned, so we can still replace it. And that event is called request handled. And I've prepared another listener for this event, which is called raise errors. Okay. And this basically reuses Laravel's exception handler class, which is able to turn a Symfony HTTP exception into a response. You know, those pretty error responses you see from time to time. So we're choosing a status code, one of those that Laravel has error views for. So if we now go into our app, we're sometimes logged in, sometimes have errors, and sometimes it's just slow. Great. Okay, let's do one more thing. I've talked about middleware before. So let's wrap a middleware around our request. And the use case here will be, we'll mess with the front end a little bit and remove all assets, or at least all style sheets from the responses generated by our app to make sure we actually get error reports, right? So we can do this by, again, hooking into the router, which has the push middleware to group. So Laravel has different global middleware stacks for different types of requests, API, web, and so on. Since we're messing with the HTML responses, we want to add this to the web stack. And again, I have a little middleware prepared, which removes some assets. So basically what this does is it passes on control to the application to get the response. And then for any response that's an HTML response, it will take a look at the content and replace all external style sheets and internal inline CSS with nothing. So depending on how lucky we get now, there we go. Okay, we got some nice basic styling. Okay. Let's finish up with the last bit of theory. I want to point your attention to this difference between these two phases, right? The boot phase, all these things happen, or let's just keep this, all these things happen for every request that passes through your app. And the things on the right side will be different for every request, depending on where it goes and what it does, etc. Okay, keep that in mind. And then let's compare the PHP request lifecycle to how it's done in some other systems. So in PHP, we usually have a web server, Apache, Nginx, that handles all the HTTP for us. And when there's a request that's relevant for our PHP app, it passes on control to PHP by starting up a new process or using one from a process pool, hands over the request, and then lets PHP do its thing, which means, in Laravel's case, booting the entire app, executing the request handler, and returning the response every time a request comes in. In other ecosystems, such as Ruby, it's quite typical to first boot the app, which then starts an HTTP server that's included in the app. And then that HTTP server will listen for incoming requests, and every time there is a request, it will only do the request handling stuff. So it can reuse a database connection that's cached in memory. It can cache other values in memory. So potentially this can be more efficient. In PHP's case, this is getting more popular as well. If you're interested in this kind of stuff, I suggest you take a look at these projects. In any case, I just, again, want to point your attention to this difference between the two phases, because the first phase, the booting, is still done for every request, although technically it might not be necessary. So we kind of want to be careful about what we do in our service providers. So they're not only foundational to or critical to our app's functionality, but also to performance. And this is also why we push envelopes into the IOC container, right? We don't want to instantiate all our services, even those that we don't need. So, such as a blade view in the view layer in the API requests, or the database in some request that just returns static data. You get the idea. So let's take a look what we're actually doing in our service providers. Again, we've been good citizens, so wrong file. So we only pushed stuff into the app in our register method, that's fine. But let's take a closer look at what we're doing in boot. So these facade calls, not sure if you know what's happening behind the scenes here. Facades basically proxy all calls to objects that they first resolve from the service container. So basically what we're doing here is we're resolving the blade compiler. Oops. Help me. From the container. And then calling extend on that. I actually like this syntax a little bit more because it's more explicit of what's going on. But then again, do we really know what's going on here? So by deferring all this logic of creation and instantiation, we have the downside of not knowing exactly what is going on here. So behind this simple app make call, this could just be a simple instantiation of one class, but it could also be sent to a manager that, or to a driver of a manager that first needs to be instantiated, including all its dependencies, which need to be pulled from the service container. So we are suddenly recursively creating an entire object graph. So this can sometimes have unintended side effects, such as generating or connecting to the database on requests where it wouldn't need it otherwise. So what can we do? We want to avoid, if at all possible, resolving services until we actually need them. And in this service provider, we are extending all kinds of services, even for requests that don't use these services. Thankfully, Laravel has our back, or the container has our back in this case, offers two extension methods itself that you can use to actually delay the executing your add-ons for services until these services are requested, resolved. So one is called resolving, and again, this is basically an event handler. So when somebody comes along and resolves the blade compiler, then please execute this closure, which will have the compiler as a parameter. And now we can just call our extension on that compiler object. So basically, we're generating another envelope and handing it into the application and telling the application execute this when you execute this and the other binding when somebody comes along and wants the blade compiler. So because this is an envelope, we again need to put this into the register method. That's the only thing you need to keep in mind. Okay, because if we keep it down there, somebody else might have already resolved our service before the listener is registered, and then it would be basically forgotten by the app. Okay. I've told you about this. So let's get to an end here. What I hope I was able to show you is that Laravel has all the tools to make customizing or hacking the framework both possible and very easy if you know the right points we're to look into. And all of this happens with zero effort and basically completely transparent to the developer of the application, which usually is a great strength of Laravel, as I'd say. In this case, it might be a downside as well. So what have we learned? The container is the tool that gives us access to all services in our application, so we can use that to hook into those services, extend them, change their behavior, replace them, and so on. Service providers are the place where we can do so, and we can add additional stuff to the app in register, extend bindings in register thanks to the container, and only pull stuff out of the application in the boot method. Finally, we can add new drivers to the various abstraction layers that Laravel has in managers. And last but not least, we understand the difference between the booting and the request handling phase, and what that means for the stuff we do in our service providers. We want to be careful not to resolve services unless we actually need them. Okay. All of this is made possible by the container, of course, which gives us access to these objects that we can extend in ways that were foreseen and intended, and also in other ways that we come up with. So this is extremely flexible. Of course, since we're doing things that probably weren't intended by the framework developer, I hope you've also learned not to trust third-party dependencies without looking at their source code. And of course, I need to warn you, don't do this at home. On the other hand, if you have good ideas what else could be done with this package, please let me know. Okay, that said, I'm sure you have good ideas. You have libraries that might be integrated or integratable with the framework. So I can only encourage you to go try it out, dive into the source code and find these extension points and use them. Because extending Laravel really isn't hard, and I hope I was able to show you exactly that. So thanks for listening, and